In this video we're going to look at a recursive function. So this is a function which calls itself. So let's say, for example, you go into the body of a function, then somewhere within that function there's actually a call to the same function, and this might happen multiple times. So we're going to use the idea of finding the factorial of a number in order to demonstrate this within our assembly language. Now, to find the factorial of a number, you just multiply the numbers out. So for example, to find the factorial of 3, it's going to be 3 times 2 times 1. The factorial of 4 will be 4 times 3 times 2 times 1. So that's the general process that we want to work through. So we have this little recursive algorithm here. Now, how do we know it's recursive? Well, we can see here that we have the factorial section here. So we have a block of code in here which is called factorial. But you can see within this block of code we have a jump to subroutine factorial. So within this code it actually calls the code again, and it will call it multiple times. So this is what we mean by an recursive algorithm. So let's talk our way through this little piece of code first of all before we see it on the actual machine. We're going to have our start address is 0x8100. We've got our defined constant and the value is n. So n is the number that we want to work out the factorial of. So in this instance here we want to work out the factorial of number 4, and we can change this to whatever number we want. So we load the value n into the index register. So this is going to load the value 4 into the index register. We then jump to the subroutine factorial. So here's a factorial here. We're going to push that number 4 onto the index register. But remember, the very first thing that happens whenever we do the jump to subroutine is that it first puts the return address on the stack. So there's going to be a return address for this point here on the stack first of all. And then we push the number 4. And then we decrement the index register. So we're decrementing it by 1. So now the index register will go to the value of 3. We're going to do a test to see whether the index register has gone to 0. So we compare 0 with the contents of the index register. Now, if it has gone to 0, then we will have gone through all of the terms, and we will go jump to if equal to out. So you can see the out here, and then we'll go through this process here. But we won't talk about this just now. Let's just talk about the options we have here. Whenever the compare function doesn't come back as true, then we jump to subroutine factorial. So we jump back up to this point here. So we don't do this at the beginning, we just jump back up to this point here. So again, we come in here and we push the value of the index register. So again, whenever we do the jump to subroutine here, it's going to put a return address into the stack first of all, and then it's going to push the next index register value, which is going to be the value of 3. And then we go through this same process with the value of 2 and the value of 1. So the first thing it's going to do is it's going to have a set of numbers within the stack. It's going to have the first return address, which is the return address for this point up here, just after this jump to subroutine. And then it's going to have the value 4. And then it's going to have the jump, it's going to have the return address. So it's going to be the return address just after this call here for this factorial. And then it's going to have the value 3. And again, it's going to have this same return address, the value 2, the same return address, the value 1, and those values are going to sit within the stack, and you'll see this just in a moment. So let's say all these values are now sitting in the stack. Whenever we do the jump if equals, so it's going all the way down so that the index register has now gone to 0. The jump if equals is actually true. So whenever that's true, it's going to jump to the out. So when it gets to this point here, which is the out routine, it's going to pop the value that's at the top of the stack off and into register R1. So the value that's at the top of the stack is the number 1. And then it jumps to the return routine and it returns back up to this position here, just after this jump to subroutine. Now, in this process of here going to the return, it returns to a particular address, and again it works its way down the stack. So after it's returned to that address, it's now in the next value of the stack. So the next value in the stack is going to contain the number 2. So then we're multiplying together 1 with 2, and we're putting the value in register R1. So it's 1 times 2 is the value of 2. And then we jump to the return again. So we go down to the return and it returns back up to the next address. So the next address again returns it back up to the jump to subroutine, or just after it, and then it pops the next value out on to the bus. So that next value is going to be the value of 3. So 3 goes into register R0. So we've now got 3 in R0 and 2 in R1. We multiply the 3 times the 2, which gives us the value of 6. And again, we go through that process, jump to return, it goes to the return, it goes back up to this line up here, and it pops the next value out, which is the 4. So 4 goes into register R0, and we've got 6 in register R1. So this does the multiplication. 4 times 6 is 24, and leaves the value in register R1. So this has worked through the whole process of generating the factorial. So whenever it has finished, and it will work through all of the values until it gets to the top of the stack, then it's going to return to the final value which is in the stack, and that return address is the return address for this factorial here. So it returns to this point here, which is the jump to end. It goes to the end and the program is finished. So it's a neat little bit of assembly language code which models a recursive algorithm. So let's see it working actually within the CPU. So I have loaded the code into the CPU, and we're going to run the simulation and we'll see it working. So the first thing that's going to happen is it's going to put the count value into the index register. So this should be a number 4. So that's at 4 in the index register, and it's going to save that number 4 in the stack. And then it's going to take the number 3 and it's going to save that number with a return address in the stack. And it's going to do the same for number 2 and the number 1. And you can see it counting down here, and you can see the value for the stack decreasing as it's creating a position for these. So when it gets to 0, I'll press stop here and we'll have a look and we'll see actually inside. So that's it at 0. So let's have a look and we'll see the values on the stack. So it's maybe a little bit small, but I think you can just about see it. So it's put the first return address in the stack and the number 4. So this first return address, if we look at our piece of code, so the first return address must be after the first jump to subroutine. So the first jump to subroutine is here, so the first return address is this return address here, which is just the end of the program. So when we get to this point here, when we work back down through the stack, it'll be at the end of the program. And it puts in the number 4, and then it puts in the next return address. So the next return address is actually the return address for the next jump to subroutine. So this is the next jump to subroutine here. So this is the call to this factorial. Okay, so the return address is just after that, so that's going to be this point here. So that's the next return address, and it's putting the value of 3 in, and then we go through that process again, and we get that same next return address and the value 2, and the same return address and the value of 1. So at that point it will have worked through all of the values within the from 4, 3, 2 and 1, and the value will then be a value of 0 in the index register. So when we get the value of 0 in the index register, it's going to, this line is going to be true, and it'll jump to if equal to out. So it's going to jump to the out position here, and this is where it's going to start popping the values back off. So whenever it pops the values back off, remember it's going to pop them back off in the opposite direction. So it's going to go from the value of 1, 8011, 2, 8011, and so on and so forth, all the way down to this point here. So it's going to take this value off here, and you'll see from the code, the first thing it's going to do, it's going to pop that value off, and it'll put that in register R1, and then it's going to go through the return, so it returns back to the address here, okay, and then it pops the next one off, which is a value of 2, and it goes into register R0, okay, so then it multiplies R1 and R0, and it puts the value into R1, so it's just 2 times 1. And then it goes through that same process again. It goes to, returns to this line here, and pops this one off, and then multiplies the 3 times the 2 from register R0 and R1, and then it goes to this address, and then pops the 4 off, and then again it multiplies out the result from the previous iteration, so it will be 4 times the value of 6, which will give us a value of 24. So finally, when it's worked through all of those, it pops the next value off. So the next value it pops off is this return address here, and this returns us back up to this point here, which is just after the very first jump to subroutine. So it jumps to the end here, and it goes to the end. So if I let this run, you'll see it running through, and I'll just slow it down so we can see it easily enough. And you'll see the values going into register R0 and R1, and we'll go through the multiplications. So there's 1 in here, and we should get the other value in this other register here, which should be a value of 2, multiplies the 2 together, it puts the result here, and then it puts the next value into register R0, which is 3, multiplies the 2 together, 3 times 2 is 6, and then gets the next value, which is 4, and 4 times 6 is going to be 24. Now remember, this is in hex, so the value actually comes out as 18, which is 24 in hex, and then it works through to the very end, and again the stack pointers come back to the original position, and then we've ended the code. So that's a nice and neat little way of providing a method of generating a recursive function within our assembly language. And recursion is a very, very important thing in terms of generating nice structures within computer programming and computer languages. So that's all for this video. Everything's in the resources section, so I do suggest you download everything and try it out for yourself. And again, you can step through every single line yourself individually to check and see that you understand what's happening throughout the code. And again, if you want to get into the minute detail, then you can always open up, and I'll leave a copy of this in the resources section as well. So you can always open up the spreadsheet, and the spreadsheet that generates all of the microcode, so that you can work through each and every line of the microcode as well. So for example, if you were to look at the jump instruction, you can find the jump instruction within here, and then you can find the actual microcode, and you can chase up the ones and zeros for all of the microcode within all of the instructions. Okay, so you can get into as much detail as you want. So that's all for this video. Thank you for listening. I will get you on the next video. Goodbye.